Hello, yes, and welcome back to our College Algebra 1.3 notes, which go over linear equations and inequalities. Now, on Friday, we talked about linear equations, and we talked about how there could be one solution, no solutions, or infinite solutions. And then we did a few examples. We saw what no solution, infinite solution looks like. And today we're going to move on. We're going to talk about linear inequalities. And to do that, we're going to get started by talking about interval notation. Now, interval notation is a method of notating intervals, which, obviously, if it's called interval notation, that's probably what it does. But in our case, we're going to use it to write solution sets, which means when we solve inequalities, we're going to write our answers in interval notation. Now, this might be familiar to some, or this might be new to some. Interval notations uses two different types of brackets. Hard brackets, which look like so, are used when the interval is contained within the solution set, which is to say if it's less than or equal to, or greater than or equal to. If the value is contained within that set, we'll use hard brackets. Now, soft brackets look like parentheses, like so. And they're used when the value is not contained, that should say not contained, how embarrassing. Not contained within the solution set, which means strictly less than or strictly greater than. Now, we'll also always use soft brackets when the interval goes to infinity. So if that interval is ever going to infinity, that infinity will always have a soft bracket, simply because you can't contain infinity. It keeps going forever and ever. We can't contain it. All right. What we're going to do now is we're going to write some of these inequalities in interval notation. So looking at letter A, x is less than 6. What that's saying is, well, x can be any value less than 6. So what's the smallest value x can be? Well, by smallest we mean most negative. Think about it as on a number line. How far to the left can we go if x is less than 6? And the answer is all the way to the left. We could go to negative infinity. All right, we can go negative infinity on that left side. And what's the largest we can go? Well, we can go all the way to 6 on that number line. Now, what type of brackets do we want to use? So notice we do least, comma, greatest, and then we use our brackets to notate it. So infinity always has a soft bracket, right, because we can't contain that. What about for 6? Well, 6, since x is strictly less than, not less than or equal to, is not contained within the solution, which means that it'll be a soft bracket there as well. So our answer would be soft bracket negative infinity, comma 6, soft bracket, which is saying x is between negative infinity and 6. It can't equal any of those, though. All right, looking at letter B, x is greater than or equal to 12. So if x is greater than or equal to 12, what's the smallest value x can be? 12. If it's greater than or equal to, that means it can go to the right on that number line. It will continue going all the way to positive infinity. So now we need our brackets. X is greater than or equal to 12, which means it can equal 12, which means 12 is contained within the set. So we'll use a hard bracket there. Infinity, of course, always has a soft bracket because you can't contain it. Looking at negative c here, negative 18 is less than or equal to x. So this one's a little tricky. I prefer to have the variable first. And if I wanted to have that variable first, all I would need to do is rotate so it would become x is greater than or equal to, and then we'll have negative 18 here. So if x is greater than or equal to negative 18, what we can do now is we need to say, well, what's the smallest x can be? Smallest value x could be would be that hard bracket, right? We need that negative 18. And then what about if it's greater than, it can go all the way to positive infinity, which means we're going to have a soft bracket on infinity there because we can't contain that in our solution set. All right, now looking at letter D, negative 3 is less than x is less than or equal to 7. So this one's really easy to see in interval notation because we can see that negative 3 is going to be the lowest number we can have, and 7 is going to be the highest number we can have. Then all we need to worry about is brackets. Now, x has to be greater than negative 3, which means strictly greater, negative 3 is not included. However, x is less than or equal to 7, so with that equal to, hard bracket there. And that's what that'll look like. All right, why don't you go ahead and pause the video. Why don't you try E through H on your own, and then we'll check those together. All right, so go ahead and try E and H, pause the video, do your best, and then we'll check them together. All right, let's check how we did. Looking at letter E, x is greater than 149. So that means 149 is the smallest value we can have. Infinity would be the largest. Soft brackets on both of those because it can't equal 149, and obviously you can't contain infinity. Negative 68 is greater than or equal to x. All right, so that's the same as x being less than or equal to negative 68. I really like putting that variable first. I think it's easier to kind of comprehend what this inequality is saying. So x is numbers less than or equal to negative 68. Well, if it's less than, it'll go all the way to negative infinity. And then we'll have negative 68 here with that hard bracket since it's less than or equal to. So negative 68 is contained within our solution. Looking at letter G, 11 is less than or equal to x, which is less than or equal to 25. So this one, we just have hard brackets, 11, comma, 25, hard bracket. There we go. X is greater than or equal to 11, but less than or equal to 25. So we got hard brackets all around to show that those are contained in the solution set. All right, looking at letter H, 0 is less than or equal to x, which is less than 15, which means we'd have a hard bracket here for 0, and then 15 with a soft bracket. Since it can't equal 15, it can only go up to it, but not include 15. All right, hopefully we're feeling good on interval notation. We're going to use this notation quite a bit as we solve linear inequalities. Now, solving linear inequalities is just like solving linear equations with a couple changes. And all it is if we multiply or divide by a negative number. All right, if we multiply or divide by a negative, we need to flip the sign of the inequality. So if it was less than, once we do that multiplication or division, then it would become greater than. We'll also graph solutions on a number line. All right, so we'll use open circle, closed circle here. So a closed circle means the point contains a solution, which is to say less than or equal to or greater than or equal to. The thing about closed circle means hard brackets, right? Open circle means the point does not contain, so strictly less than, strictly greater than. Those are soft brackets in interval notation. So we can kind of make that connection between our number line in interval notation and our inequality. So let's look at a couple examples here. Let's knock these out. All right, solve the following inequality, graph the solution on a number line, write your answer in interval notation. I'm going to zoom in just a little bit so we can give myself a little more space to write. All right, negative 2n plus 3 times the quantity negative 4n plus 6 is greater than or equal to negative 7 times the quantity 1 plus 2n. So first things first, I'm going to take care of some of this distributing. I'm going to distribute that 3. I'm going to distribute this negative 7. That'll give me negative 2n minus 12n plus 18 is greater than or equal to, let's see, that'd be negative 7 minus 14n. All right, so negative 2n minus 12n is negative 14n plus 18 is greater than or equal to negative 7 minus 14n. All right, looking at this here, oh, I see what's going to happen. If we add 14n and we add 14n, when I do that, I get 18 is greater than or equal to negative 7. I always like to start with a problem like this because it makes you think, well, is this a true statement? Is this a false statement? Notice our variables are gone. This kind of relates back to our no solution, infinite solution idea we talked about with equations. Now here, 18 is greater than or equal to negative 7. In the past, we'd say infinite solutions, which is, I mean, true, I guess, but with inequalities, we generally always have infinite solutions, as any inequality goes to positive or negative infinity most often. So 18 is greater than or equal to negative 7 is true. However, what we would say here is all real numbers, in the sense that all numbers from negative infinity to positive infinity are our solutions. So on my number line, what would that look like? I'd plot a couple points like 0 and 7, and then that number line would go all the way in both directions. So what would that look like in interval notation then? Well, my smallest value would be negative infinity, and my largest value would be positive infinity. This is a true statement, which means all real numbers. So any number on the number line would satisfy this equation, so negative infinity to positive infinity are our solution in interval notation. Very nice. Let's look at letter B now. negative the quantity m minus 7 minus 2 is greater than or equal to 5 times the quantity 1 plus m. So distribute that negative, distribute that, and then distribute this 5. All right, so we'll have negative m plus 7 minus 2 greater than or equal to 5 plus 5m. All right, so let's combine some terms. So we have negative m plus 5 is greater than or equal to 5 plus 5m. We can add an m to both sides, add m. So we have 5 greater than or equal to 5 plus 6m. Subtract 5, subtract 5. 5 minus 5 is 0, greater than or equal to 6m. Divide by 6, which tells me that 0 is greater than or equal to m. However, remember, I like my variable first, so I'm going to say m is less than or equal to 0. So there's my solution as an inequality. M is less than or equal to 0. So on a number line, I'd plot 0 like so. I can plot negative 3 right there. Less than or equal to 0. So at 0, I'd have a closed circle. And since we're going less than, we'll be going to the left. All right. Now in interval notation, the smallest value we could have would be negative infinity. So we went to the left. The highest 0, hard bracket there, because that 0 is contained within our solution set. All right. Let's look at letter C now. Negative 3 times the quantity 2r minus 5 is less than negative r plus 30. So negative 3, distribute that. When I do that, I get negative 6r plus 15 is less than negative r plus 30. All right, so I'm going to add r to both sides. When I do that, I get negative 5r plus 15 is less than 30. And then I'll subtract 15. 30 minus 15 is 15. And look what we have here. Negative 5r is less than 15. I divide by negative 5 on both sides. So divide by negative 5, divide by negative 5. When I do that, we should have some alarm bells going off in our head. Because if I'm dividing by a negative, that means I need to flip my sign. So this will become now r is greater than negative 3. And that would be my solution. R is greater than negative 3. So I'm going to plot negative 3 there. I'll plot 0 here. If r is greater than negative 3, I'll have an open circle above negative 3. And greater than would be going to the right there. In interval notation, soft bracket negative 3 all the way to infinity. There we go. Questions? Awesome. Looking at, I don't know why I ask questions. It's not like I'm there. I can't really answer that. If you have any questions, feel free to check in with your partner, I suppose, see if they can help you out a little bit. Looking at letter D, the negative quantity of negative 4p minus 3 is less than 7p plus 3. So let's start by distributing this negative here. When I do that, I'd have positive 4p plus 3 is less than 7p plus 3. I see. Subtract 3, subtract 3. So 4p will be less than 7p. Subtract 4p, subtract 4p. When I do that, I get 0 is less than 3p. Divide by 3, divide by 3. And I would end up with 0. Oh, shoot. I would end up with 0 is less than p, which means that p is greater than 0. Fantastic. So if p is greater than 0, then I would say, all right, 0 to infinity in interval notation. On my number line, mark 0. You can mark some number here. Let's say 5. Open circle above 0, and since it's greater, I'm going to the right. P is greater than 0, like so. All right. Why don't you guys go ahead and try a couple on, well, no, let's do letter E together now that I see it. This is a compound inequality. All right, looking at this compound inequality, negative 13 is less than or equal to 7 plus 4x, which is less than 35. If you see something like this, our goal is to get our variable isolated in the center of the inequality. So let's do that. Now, when I do an operation, I have to do it to all three expressions here. So I'm going to start by subtracting 7, because my goal is going to get x in here. So I'll have negative 13 minus 7, which is negative 20. That's less than or equal to now 4x, which is less than 28. Alright, so negative 20 is less than or equal to 4x, which is less than 28. I got to get x all by itself, so I'll divide by 4, divide by 4, divide by 4. When I do that, I get negative 5 is less than or equal to x, which is less than 7. And that would be my solution there. Alright, my solution set's negative 5 is less than or equal to x, which is less than 7. So on my number line, I can plot negative 5. Go ahead and plot 0 just to be cute. Plot 7 there. Negative 5, close circle since it's less than or equal to x. 7, oh, no, that need to be an open circle since it is greater than x. And then I would just connect my dots like so. There we go. All right, with that being said now, in interval notation, I'd have a hard bracket, negative 5, and then 7 with that soft bracket for that. All right. Looking at letter F, 1 plus 3n is less than 5n plus 7, which is less than or equal to 9 plus 3n. Woof. All right, so again, the goal is to isolate that variable in the center. So I'm going to start by getting rid of these variables on the outside by subtracting 3n from everything. So I'm going to subtract 3n from everything. When I do that, I'm left with 1 is less than 2n plus 7, which is less than or equal to 9. Now I'll subtract 7 from every expression. When I do that, I will have negative 6 is less than 2n, which is less than or equal to 2. Divide by 2, divide by 2, divide by 2. I'll end up with negative 3 is less than n, which is less than or equal to 1. And then I can plot that really easily on my number line. I'd have negative 3. I can go ahead and put 0, put 1. 1 would have a closed circle. Negative 3 would have an open circle, of course, strictly less than or equal to. Make sure that shows on the number line. Connect my dots like so. In interval notation, I'd have a soft bracket, negative 3, comma 1 with a hard bracket. That 1 with the hard bracket because less than or equal to. Soft bracket because strictly less than there. All right. How are we feeling on these? Hopefully pretty good. Goodness, let's try one of these together and then I'll let you do the other one on your own. So let's start with, let's do letter G here. All right, 5/4 times the quantity 13/3 in plus 5/2 is less than 5/2 times the quantity 4/3 in plus 3/2. All right, multiplying fractions. 5 times 13 is 65. 65 over 12 in plus, obviously I'm distributing this here. 5 times 5 is 25 over 4 times 2 is 8. And that is less than, gotta distribute this 5/2 here. 5 times 4 is 20 over 6n plus 5 times 3 is 15 over 4. Woof. Ugh, this is gross. Alright, so we got all sorts of numbers going on here. Let's see. What would be the smartest way to approach this? So there's a couple ideas I'm thinking through here. One, we could either try to get common denominators for all of these, which would be 24, or we could get common denominators for the coefficients with variables and the coefficients of the variables and the constants here. So in that case, it'd be 12 and 8. But you know what? I think our best bet here would be to try to get common denominators for everything and then just multiply by that common denominator. So that being said, we need 24 in our denominator. So 65 times 2 is 130. So 130 over 24 in plus 25 times 3 is 75 over 24 would be less than 20 times 4 would be 80 over 24 in plus, and then if we need 24, we'd have to do 15 times 6 is 90 over 24. Gross. All right, so now that that's done, I can multiply everything by 24, multiply by 24, divide that out, divide that. All that gets divided out. I'm left with 130n plus 75 is less than 80n plus 90. And this is something that's much nicer to work with. So I can subtract 80n from both sides, subtract 80n. When I do that, I get 50n plus 75 is less than 90. I can subtract 75, subtract 75. When I do that, I get 50n is less than 15. Now I'm going to take this up top here so that I got a little bit more space. So 50n is less than 15, divide by 50, divide by 50. When I do that, I would get n is less than 15 over 50. I can take a 5 out of each of those, and that would reduce to 3/10. So n is less than 3/10. So on my number line, plot 3/10. I can plot 0 here too. I'd have an open circle since it's strictly less than, and we'd be going to the left since it's less than. In interval notation, I can see that this would go all the way to negative infinity and go all the way up to 3/10, soft bracket there. There we go. All right. Whew. Hopefully we're feeling good. I want you to try letter H on your own. So go ahead, give yourself some space here. Try letter H. Go ahead and pause the video. Give yourself your best shot, and then we'll check it together, all right? All right, let's see how we did with letter H. So start by distributing. So I'd have 3/2 times 7/4 x. So 3 times 7 is 21 over 8x minus 3 times 3 is 9. 2 times 4 is 8. There we go. And that'll be less than negative 15/4 plus 3/2 x. So using what we did on letter G, hopefully we saw now, let's get some common denominators. So 8 would work here. So 21x over 8 minus 9/8 is less than, I need to multiply this by 2, so negative 30/8, 2 over 2 of course, really I'm multiplying by 1, and then multiply this by 4, so 12 over 8x. Multiply both sides of the inequality by 8, and all of those 8s would now divide out. So I'd be left with 21x minus 9 is less than negative 30 plus 12x. All right. Whew. All right. Well, let's subtract 12x from both sides. Subtract 12x. When I do that, I would get 9x minus 9 is less than negative 30. Add 9. Add 9. When I do that, I would get, I'm going to draw it over here. 9x is less than negative 21. Divide by 9, divide by 9. No need to flip the sign because I'm dividing by a positive number, even though my dividend is negative. My divisor is positive, so no need to flip here. That's less than negative 21 ninths. I can take a 3 out of both of those. It would become negative 7/3. All right, so on that number line, I'll plot 0. I'll plot negative 7/3. Strictly less than, so an open circle going to the left. In interval notation, we'd have negative infinity to negative 7/3, soft brackets all around. All right. Hopefully we're feeling okay with these inequalities. I think that's where we're going to stop today. So if you're done, fantastic. If you have any questions, feel free to ask the people around you, see if they can help you out a little bit. Otherwise, go ahead and get to work on your practice problems, get to work on those inequalities in there, and then we'll have a new lesson and we'll finish these, we'll have a new video to finish up these notes tomorrow. So I'll see you then.